In this series of videos, I'm actually going to go over um, all of the questions from the first midterm exam in CS 2401 for the spring of 2020. The idea is not only to go over the answers to the questions, but also an explanation of how to read the question, how we think about the question, and how we think about trying to solve that question. So I'm going to make 5 separate videos, um, 6 separate videos, one for each of the 5 questions on the exam, and then one for the extra credit question at the end. So this way, you only need to look at the videos related to the questions that you might have questions about or you think you need to review. So let's get started with question number 1. So here, what we're being asked to do is assume you're given a square 2D integer array. So here by square, we mean that both the length and the width are equal. And in this case, each of the rows is full. So all of the rows have the same width. And we want to compare the number of occurrences of a given integer in the diagonal versus the anti-diagonal. So the diagonal is going from the top left to the bottom right, and the anti-diagonal is going from the top right to the bottom left. In this example down below, the diagonal and anti-diagonal are shown in bold and italics respectively. Right?
What the question is asking is that we return an integer value that's greater than 1 if the diagonal has more occurrences of that selected search integer, and less than 0 if the anti-diagonal has more, and it's going to be 0 if they're equal. So we've been given 2 examples here, and we can see the diagonal has 4 values, -2, 6, 2, and 5. The anti-diagonal has 4 values, 5, 8, 0, and 5. And we're given the array as well as an integer 5. So we can see the diagonal has 1 occurrence of 5. Change this color. Right. Just the 1 occurrence of 5. The anti-diagonal has 1, 2 occurrences of 5. Right. So what we want to return, the return value is greater than 0 if the diagonal has more occurrences, and less than 0 if the anti-diagonal has more. So the anti-diagonal has more, which means the return value should be negative. Right? And in this case, it should be -1, right, because it has 1 more occurrence. Sorry. In this second example, we're given the following array and the search integer -2. So the diagonal has 1, 2 instances of -2, right? And the anti-diagonal has 1, 2 instances of -2, right? So in this case, the return value is 0 because the anti-diagonal and the diagonal have the same number of occurrences. Right? They both have 2 occurrences. Even though one of those is shared, they both have 2. Okay, so the summary here then says your task is to design a Java method called compare diagonal anti-diagonal count, which takes a 2D integer array. It should be square, right? It said it was square up here. And a search integer. And what we want to return is an integer whose value is positive if the diagonal has more occurrence of the search integer, negative if the anti-diagonal does, and 0 if they're equal. The key here is that the value of which corresponds to the difference in the number of occurrences between the two. Right? So in all of these examples, right, in all of these examples, the value is either -1, 0, or 1. Right? But if we did have the case where instead say this value on the diagonal is 5 as well, right? So instead of a 0, we had a -5, right? Well, then the anti-diagonal would have 3 values, right? And the diagonal would still just have 1. So in this case, the return would be -2, right? Because the anti-diagonal has 2 more occurrences than the diagonal. Okay, so now we know what the problem is. The question is, how do we go about trying to solve, to write the solution that we're looking for, right? Well, we know we're going to need to actually count the number of occurrences of these two, of the search value on the diagonal. We're also going to need to count the number of occurrences on the anti-diagonal. And then we're going to need to compare them. So the first thing we should do is be able to move this text over to the right screen. There we go. And I don't want it to be bright red. I want it to be, let's say, 14 point blue. And I want it to be left justified. And since it's code, let's make it courier. Okay. So the first thing we need to do is to count the number of matches on the diagonal. And we need to count matches on the anti-diagonal, right? And then once we count the matches, we need to compare and return a value. Okay. So now that question leads us to, well, how do we count the number of matches on the diagonal? Right? Well, we know we're going to need to keep track of how many we've seen already. So we're going to need some sort of integer. And even though in Java integers are defaulted to 0, let's go ahead and set it to 0 anyway. And then we're going to need to look at all of the values on the diagonal, right? So on the diagonal, we know we have the value 0 at position 0, 0, 1, 1, 2, 2, 3, 3, right? 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. So in order to do that, do we need two nested loops? Even though it's a 2D array, so we should have to use 2 nested loops, right? Well, since we're only looking at the diagonal, we really only need 1 loop, right? It's only going to be those single values along the loop. So we're going to do a for loop. Let's remember to put in all of our opening and closing brackets. And it's going to go, we're going to use integer I. And it's going to go from 0 to what? Well, our array is this guy ARR. And we know that all of the rows and columns are the same size. So ARR.length will suffice. Right. And we're going to increment that by 1 every time. Okay, so now we are looping through all of the items. We're going to be looking at the item in ARRI, right? Because it's going to be on the diagonal. And what do we need to do with that? Well, we need to check if it's equal to search, right? And how do we normally check something? Well, with an if statement. So if ARRI is equal to search, then what? Well, now we know that the element at II, so one of these places along the diagonal, is equal to our search integer. Well, if that's true, then we need to increase our counter. Right? Is there anything else we need to do to put inside this loop to make it work? No. It's just fine. So now we need to count the things on the anti-diagonal. And we know, so the first thing we're going to need, again, is an integer to hold the values, right? And what are the positions that we need to look at for the anti-diagonal, right? It's 0, 4, right? Is this guy? Or, sorry, 0, 3, 1, 2, 2, 1, 3, 0. Right? Or over here, it's 0, 4, 1, 3, 2, 2, 3, 1, 4, 0. So what do those all have in common? Zero, 4, 1, 3, 2, 2, 3, 1, 4, 0. Well, if the first index is I, what's the second index? Right? All of them satisfy that criteria. So, with that said, do we need one loop or two to be able to get all those values? Right, we still only need one loop. So we're going to use one for loop. And here we're going to use j. J is less than AR.length. J++. And just for fun, let's set a new variable, int j. Let's call it k, right? And that's equal to ARR.length minus 1 minus I minus 1 minus j, right? So that gives us exactly the other index. So given that we have I, right? If I is 0, or sorry, if j is 0, then this is, here it would be 5 minus 1 minus 0, which is 4. Here it's 5 minus 1 minus 1 is 3. 5 minus 1 minus 2 is 2. 5 minus 1 minus 3, so on. Right? Okay, so now we are looking at the item in ARRJK, right? And what do we do when we look at it? Well, it's something very similar to what we did for the diagonal, right? We need an if statement, if ARRJK equals search. Then we need to increase the anti-diagonal count. And we're done. Notice through all this if I move this down so we can actually read it. Notice that through all this, I don't change the value of search. Right? Search is not the counter that I'm going to be using. Search is the thing I'm checking, to see if the item in the particular element we're looking at is the value that we're looking for. Okay, so now I have these two values in diag count and anti-diag count, right? And we need to return a value. So if we look back here, right, we need to return a value that's positive if the diagonal has more occurrences of search, negative if the anti-diagonal has, and the value of which corresponds to the difference in the two numbers. So we know we're going to have to look at the difference, right? So we know we're going to have to look at diag count. Oh, I did make a mistake here. Minus anti-diag count at some point, right? Well, let's look at that subtraction for a second. That difference is just if the diag count has more, right? If we saw more on the diagonal, then that value is positive. Well, that satisfies what we want it to do. If anti-diag count has more, then the value is negative and it satisfies what we want it to do. If they're equal, it's 0. And the absolute value is the difference between the two. Right? So that's the value we need to return, right? Is just this difference. So what did we do? We looked for all of the elements on the diagonal that matched our search value and counted them. We looked for all the things on the anti-diagonal, checked if they were equal to the search value, and we counted them, and then we returned the difference of the two. All of that satisfies our original question, right? And we're done, right? Did we make any mistakes here? Are there any missing semicolons, unmatched curly braces? No, looks good to me. Okay, so then moving on to the bonus question. This is a technique used to compare objects. Which method for string objects is this similar to? We talked a little bit about this in class. So the reason I made it a bonus question is because I didn't touch on it super deeply, and some of you got this right. But what's the answer? So it returns a positive value if something, returns a negative value if one comes after the other. Well, it's similar to compare to, right? So string dot compare to some other string returns a negative value if the original string comes first, returns a positive value if the original string comes after, right? And that's exactly it. So be on the lookout for the next question in a separate video, and I will